this unit, we're going to understand how to take a formula and solve it for a different letter, or rearrange it or reevaluate the formula again for a different variable. We sometimes call this solving a literal equation. We're also going to understand subscripts. What I mean by this, x to the second power, that's a superscript. Subscript x sub 2 is when that real small number is low. P sub 1 would stand for maybe the pressure at time 1, and P sub 2 would stand for the pressure at a different time 2. So subscripts. We're also going to solve a formula for a variable, and then we're going to substitute numerical values in to use it. So that's the purpose. Very, very important in all of our sciences. Probably one of the most important algebra skills that we need if we're studying in an engineering program. Okay, so we're going to take these formulas that you see here. Every once in a while I'll tell you where they're used, but basically they are used in a technical or a scientific area of study, and we're going to solve these formulas for a different letter. But before we do that, for example, this first problem, E stands for the voltage in a circuit, and the letter I stands for, maybe I'll come over here and do this. E stands for voltage. I'm going to put volts. I stands for the current. Amperage is the unit of measure for that. And R stands for resistance. And in this particular problem, we want to rearrange this formula and solve for the letter R. Well, what I want to do, and I'm going to erase this once I've done it, I'm going to put a different problem right below this. I'm going to put the problem 4 equals 2 times x, and I'm going to say to you that I want to solve this equation for x. Well, because that says 2 times x, I'm going to divide both sides by 2 in order to get x alone. So again, I've solved for x, and 4 divided by 2 is 2. Well, this process, this multiplication principle, which is we divided by 2, but that's the same thing as multiplying by a half. If I want to get r alone in this problem, it's got in front of it an I, just like this x had a 2 in front of it. So to get rid of this 2, I had to divide both sides by 2. So I'm going to erase my work here, and I want to get r alone, and I'm going to do that by dividing both sides by the letter I in order to get r alone. So now what I have is E divided by I is equal to R. So say I wanted to know the resistance in a problem, and I was given the voltage and the current, I could substitute those two numbers in and divide them, and that would give me the resistance in the circuit. So I'm doing this because the original problem gave me solve for the voltage. So the voltage was equal to the current times the resistance. That's fine if I know what the current and the resistance are. I can put those in and multiply them together to get the voltage. But again, the reason I'm doing it is, say I know the voltage and the current and I want the resistance, I'm going to rearrange that formula first for the thing that I want to solve for. Okay, let's go to the next one. So question number 2. PV equals R times T, and I want to solve for this letter T. Well, it's got an R times a T, not just a T, an R times a T. So to get that T alone, I have to divide both sides by R, and I'm all done. I'm going to go ahead and write here the new formula. T equals P times V divided by R, and the reason that worked out was because these R's cancel out, getting T all by itself. So let's go ahead and work on some problems that are a little bit harder. So the next one, E equals mv squared over 2. A couple of things. First of all, I'm looking to solve for, sometimes I will highlight what I'm looking to solve for. I'm trying to get this m alone. Now, I have lots of options, but one of the things I like to do is clear the denominators. So I like to multiply both sides by 2 to get rid of that denominator. So 2 times e equals mv squared. And the reason I did that was to get this 2 and this 2 and make them go away because they're equal to 1. 2 divided by 2 is 1. And now I can solve for m because it's m times v squared. So I'm going to divide both sides by v squared in order to get m all alone. So these are going to be gone. And now I do have m all by itself, and it's equal to 2 times e divided by v squared. You know, there's other ways to approach these problems. You know, one option, so let me just put a little squiggly here. One option is to think of the original problem as e over 1 equals mv squared over 2. And because it's a proportion, then you can set the cross products equal. So set that product, 2 times e, equal to 1 times mv squared, which is just mv squared. So again, 2 times e equals mv squared. And that's pretty nice. Now, mind you, that's what I had right here. So I got myself to the same spot, but I just thought of this problem as a proportion, and now I divide by v squared. Let me show you another choice here, just in case you're thinking about it. So e equals mv squared over 2. I'm going to put that 2 kind of under this v squared. I want to get m alone, and some people look at that v squared over 2 and they say to themselves, well, let's just multiply by 2 over v squared, which is the reciprocal of the v squared over 2. If you multiply by 2 over v squared, then all of this becomes 1, and it's gone. So you have 1m. But if you do it to one side, you have to multiply the other side by 2 over v squared. So again, let's go ahead and just show that the v squareds canceled out, the 2's canceled out, and you were left with, on the right-hand side, m all by itself. So, you know, many approaches to solve a formula. And I'm often going to use the proportion approach. Let's go ahead and do a few more problems on the right side here. So let's go back, let's go up to number 4. So I just want you to know this one, boy, I'm trying to think of where this formula stems from. I'm afraid I cannot remember at the moment. This is the letter L, and I like to think of that as L over 1. And therefore, I'm going to set this cross product equal to that cross product. So I'm going to have LMR is equal to 1 times yd, which is yd. Again, remember, look, I'm solving for the letter r, so this reads L times m times r. So to get that r all alone, I'm going to divide both sides by the little l and the little m. And now I have canceled those out because those are equal to 1. And I have rearranged this formula for the letter r. And it's found by taking y times d divided by l times m. So same thing goes with number 5 and number 6. To be honest, I think of this as an r over 1, but really I just go ahead and bring this l over here. It'll be r times l, and then g sub 2 minus g sub 1. In the intro to this video, I suggested that these subscripts often, maybe, you know, this can't be gravity, but say it was. It's gravity at time 1 and gravity at time 2. I suppose it could be gravity on Earth and gravity on Mars, but it's representing something that's the same type of item, same units, but it's sometimes at different periods of time. So that's what this is all about. Now, when I solve an equation where I have two terms over here, g sub 2 minus g sub 1, and I want to get g sub 2 alone, I want to get this one alone, it's got a minus g sub 1 hanging out with it. So I've got to add g sub 1 in order to get rid of it so that these two will disappear. Well, then I better add g sub 1 over here. So the right side of my equation becomes r times l plus g sub 1. That's my left side actually, and that equals g sub 2 on the right. And I have solved this equation for g sub 2. One more time. So, what's really, really challenging about this one is that your unknown is downstairs. A lot of people think that they can divide by TP and multiply by pi L, and D will be alone. In other words, multiply by this reciprocal. But it is downstairs. It's got to be brought upstairs before you can do that. So I'm going to go ahead and take this product. I'm multiplying T by the pi LD, so T times the pi LD, and letting it equal to the 2p, because this is 2p over, t over 1, so set it equal to that 2p. Now it's easy to solve for D, because D is upstairs, and D is multiplied by these 3 letters, so to get rid of them, I'm going to divide by T and pi and L, both sides. This is a concrete related problem. So now the T's, pi's, and L's cancel out, and I do have D all by itself, and it's equal to 2p divided by T pi L. I'm going to stop for a moment. Why don't you go ahead and practice on the next page of the worksheet.